For several years, I've been optimistically awaiting the commercialization of sodium-ion batteries, and I was really pinning my hopes on U.S. startup Natron Energy, which was planning a $1.4 billion factory in North Carolina, and then it went out of business in late 2025. I'd been excited about sodium-based battery chemistries because they're more stable than other lithium systems such as lithium-iron phosphate, LFP, or nickel-manganese cobalt, NMC. Sodium batteries can operate safely over a much wider range of temperatures, especially cold weather, and they have extraordinarily long cycle lives, up to 20,000 cycles versus about 7,000 for lithium iron phosphate and 2,000 to 3,000 for nickel-manganese cobalt batteries. And sodium batteries are inherently less costly than lithium-based alternatives. There's a ton of salt in the world if they can be manufactured at volumes that can drive economies of scale. The biggest knock on sodium technologies is energy density. The International Energy Agency recently reported that latest sodium-ion cells achieve around 175 watt-hours per kilogram, compared with about 205 watt-hours per kg for LFP batteries and 255 watt-hours for NMC batteries. That matters for electric vehicles that have to haul the weight of those batteries around, but it's far less important for stationary storage that serves our power grids. Until recently, the EV industry set the stage and dominated the terms for the stationary storage battery space because the global EV market provided the scale for battery development and manufacturing. Stationary storage was kind of like a tick on the electric vehicle dog. Wherever the dog went, that tick went along for the ride. But with today's scale in the global electric power industry, that storage tick, well, it can essentially blaze its own path. A fact perhaps nowhere better illustrated than Ford's May 11th announcement that it was forming a subsidiary, Ford Energy, and repurposing its originally designed EV battery factory to address the storage opportunity, although it won't be a sodium-based battery. Ford's Energy factory will churn out 20 gigawatt hours annually, with EDF just announcing it will take about 20% of that output over the next 5 years. So when you hit that kind of scale, it makes sense to press the accelerator on improving manufacturing and deploying sodium batteries more broadly. And the good news on the manufacturing front is sodium scale-up can take advantage of existing lithium-ion battery production lines. It's a very similar manufacturing process. Estimates are that when the industry does fully scale, a sodium battery will have a 25 to 30% lower material cost tab than a comparable LFP battery, for example. And fortunately, despite Natron Energy's demise, U.S.-based startups continue to soldier on. One leading contender is Peak Energy, which in November of last year announced a multi-year agreement with developer Jupiter Power for up to 4.75 gigawatt hours of sodium-ion battery energy storage systems to be deployed between 2027 and 2030. An initial 720 megawatts of that will be deployed next year. Last year, Peak also announced it had shipped its first sodium batteries to be used in a shared pilot with 9 utility and independent power producers. The company touts its battery storage package as being the first ever fully passive system, meaning it requires no active cooling, fans, pumps, or other moving parts. The stuff that can break down represents about 85% of the root causes behind battery system failures. That's a good start here in the U.S., but if you want to see where sodium-ion batteries are likely headed in the future, you have to look to the same country that's dominated manufacturing and commercialization of solar panels, lithium batteries, and EVs for much of the last decade. That's China. That country cranks out over 75% of the world's lithium-ion batteries, and it dominates the space. Peeling that back a bit further, you need to look at not only China, but specifically at what contemporary Amperex Technologies, CATL, is doing in China. CATL, or CATL, is to batteries kind of what NVIDIA is to AI chips. It dominates the market. In this case, it commands nearly 40% of global market share, so less than NVIDIA, but it dominates and means to continue that position. It does so by possessing a staggering manufacturing capacity while also investing heavily in R&D. In late May, for example, it held a 20-plus acre, $440 million one-stop testing and validation platform proving ground that it is designed as an open and shared infrastructure accessible to all players in the global energy storage sector. Its global innovation network comprises 6 R&D centers, plus the one just announced, and employs 23,000 R&D personnel, with well over 50,000 domestic and international patents either granted or pending. So yeah, pay attention to what CATL does. The rest of the battery herd will eventually follow. CATL's most recent and meaningful announcement on the sodium battery front is a strategic cooperation agreement with Chinese firm Hyperstrong on sodium-ion batteries. That single arrangement, just recently announced, calls for 60 gigawatt-hours of sodium-ion batteries, by itself exceeding the 58,000 gigawatt-hours of lithium batteries installed in the U.S. last year, per figures from the Solar Energy Industries Association. CATL and Hyperstrong, in this first strategic partnership for sodium-ion energy storage, will collaborate in areas including technology, R&D, product applications, and project development. You should probably always take my predictions with, well, a grain of salt, but I'm fairly confident that sodium-based battery chemistries are about to mainstream in the electric power industry, first in China, and then eventually peppering the landscape in grids nearer to you. Well, thanks for watching, and we'll see you again soon.